Hey guys, my name is Freedom. Today I'm going to show you how to create the bouncing physics 3D animations simulations in Blender 4.2, and everything will just follow the real life situation, the real life physics with the bouncing, with the damping, and also decrease of the bouncing, and also increase of the bouncing rate, something like this. It is going to simulate everything, start from beginning. And actually, I derived from the really basic concepts of the Blender. One frame is 1/24 seconds, and all of the physics of the bouncing ball. I already made all of the derivations. And just believe me, I'm a physicist. And finally, I already get the conclusions. What you need to do is just follow this 5-minute tutorial. You can just ignore all the derivations. Just use the formula given by me. This is the final formula. So I'm going to show you from beginning. Just start a fresh new project, and I don't save this. Alright, first what you need to do is at here you need to create an empty or just a circle mesh and just make it as a reference, because later you need a sine graph. Alright, so I click the empty area, I press A and press delete button to delete everything, and I will just add a circle. Then this circle, I'm going to add a empty and just press S to just make it small, and then I will push it to this point so that you can see it. This is -1 and press enter. Then I click the empty and hold the shift, click the circle, Control P to bind this as the object. Now, this is the circle. And then, we are going to make these rotations. Alright, you can see the N will be the number of initial bouncing per second. And this is the whole formula. We are going to make it as driver. B is the bouncing increase constant. Alright, first we apply this. I'm going to just copy this one. And I will just use another one, another notepad here to paste it and do some. So usually the N, I will just put 1, the number of bouncing will be 1. And then here, the B, I will just put 0.01. Alright, now I just copy this and paste it at rotations. So here, click the Z, click the circle, select the circle, then Z. You have to type a hash, then Control V to paste it here and press enter. Now you can see it is a rotation. Next, we are going to create a ball. Just add a mesh, add a UV sphere. Just press S to just make it small, like this. Alright. Next is just set up a bouncing object. This ball will be your bouncing object. Set the height of the bouncing object by using driver. So this is the equations. We are going to use the rotation reference as driver. So first, before we apply the formula, for this one, the location Z, we are going to just right click and add a driver. Then, move this up, move your mouse cursor to the corner and drag it down. This one, we select driver. At this moment, you need to click the ball, click the Z locations, and click the driver, scroll up. Now, the object, what is the reference? Just choose the circle. Then the type will be Z rotation. Alright, next is the expressions. The expressions, we are going to follow this. H is the maximum height, and the K is the damping constant. So now, I copy this and just paste it somewhere first and do some. So let's say the maximum height I want to put as 5 meter. This one will be in meter. Then the K I will just temporarily put 0.01 and have a look first. Alright, so now I copy and paste it at here. Sorry, just paste it here, Control V and press enter. Now try to play. Alright, some more, you still can do some adjustments. Let's say, just now the circle, this is how it increased the frame. Let's say here, if you put 0.003, then try to play again. You can see the increase of the rotations will decrease. For this time, it is still bouncing. Maybe you want to just make some changes. For this ball, the maximum height is 5 meter. We click here to see which one is 5 meter. It's somewhere here. So initially, it will be at here. This is the maximum and started. The damping coefficient, we can change it. Just change the K value. I put it as 0.03 as well. Just try to play. Alright. What about if I put it as 0.05? Then just observe. It depends on what type of the effect that you want, because different material it have different bouncing rates and also the elasticity. So for all of this formula, you can change all these constant. The number of initial bouncing per second, the maximum height, etc. to fulfill your needs, to fulfill your desire, you can change it. Let's say for this, the maximum height, just now I put 5. If I put it 10, then I change it to 10. Now have a look. For this time, I may want to change the rotational increase rate at here, maybe 0.01, and just try. Alright, not so good, then change it again, let's say 0.05. The most important one, we have to just make it look natural. 0.03. Zero 0.04. Right. 0.07. You can just make it until you feel it is nature. You feel nature, you feel it is okay, then, well, everything will be okay. So finally, it is the damping, 0.05. What about if you put 0.09? Right. So here, 0.01. This is the damping. Right. So just put a suitable value so that you will feel natural, then that's okay. So for me, I feel this okay already, then I can just using all of these numbers, and I can render a video just by using this formula. Alright, that's all for today about my tutorials on how to create a bouncing ball. Just follow the physics law, and just believe me, all the derivation I already make it, but in this tutorial, this is just a very short tutorial. I'm going to just share my finalized equations. You can just use it and generate the bouncing ball very fast by using the final equations. Alright, that's all for today. Thank you for watching. If you love my videos, tutorials, and sharings, if you feel all these tutorials and sharings are very helpful to your 3D modeling, 3D animations, and 3D game developing, You can subscribe to my YouTube channel and also turn on the mini bell and select all so that when next time I publish a new videos, tutorials and sharings, you receive a notification immediately. See you in my next video. Enjoy! Happy 3D modeling, 3D animations and 3D game developing. See you!